So hi coders, today we're going to solve some problem from Leetcode top interview questions. So here's the problem. So given an array of integers, nums, and an integer target, we need to find the indices of two numbers such that they add up to target. Okay, so there is only a single solution exists in this problem. So you can return the answer in any order. Okay, let's see the example. In this example, there is a array which have 2, 7, 11, 15 as an element and the target is 9. Okay, we need to find two elements as that their sum is 9. Okay, let's take 11 and 15. So there is sum is 26. So which is not equal to target. Let's take 11 and 7, which has sum 18, which is not equal to target. So let's take 7 and 2, which add up to 9. So this is our answer. So we return its index. The 2 index is 0 and 7 index is 1. So we'll return this as a vector. Okay, let's take example 2. So in this example we can see there's a array which have 2, 3 to 4 as an element and 6 as a target. So let's take 3 and 2 which sum up to 5, which is not equal to target. Let's take 4 and 3 which sum up to 7, which is not equal to target. Last combination is 2 and 4, which sum up to 6 and which is equal to target. So we'll return its index. Okay, let's talk about the solution. So let's take this example. So this is the array we are given and this is our target, which is 18. So what we can think is, let's try all possible combination of two elements and take its sum and check if it's equal to target. If any two element sum is equal to target, then that will be our answer. Okay, let's try this 2 and 7 first. So it's add up to 9, which is not equal to our target. So let's try 2 and 11, which add up to 13, which is not equal to a target. So we will try all possible ways like this. We try with 2, all the combination we can form with 2. Then we will try with 7. So we will form all possible combination, for example 7 and 11, then 7 and 15. Then after completing 7 we will start with 11 and 15. Then the loops end. So in this way we'll form all combination until we reach our target. Okay, let's talk about its time complexity. So what we are doing, basically we are fixing an element, trying all possible combination we can form with other element. So in this way we are iterating it O of n times into n elements. So like we are fixing first element and trying all other elements. So it's simplified to the O of n square. So this is time complexity. And for about space complexity, so we are not taking any space, so this is O of one solution. So it's like a very slow comparatively. So the question is, can we optimize it? Okay, let's see its optimal approach. With the problem state, we need to find two integer nums of I and nums of j which sum up to target. Okay, we can pick any two integer. Let's say we pick nums of I as 11. So we need to find any integer which sum up to 18. So okay, so we know that only 7 is possible. So we, how did we find 7? We will just basically subtract 18 minus that given element, so which will result in 7. So we need to find 7 in our array. If it's present, then that will be our answer. Okay, let's start from 0th index. So which is 2, which is not equal to 7. Then first index is 7, what we required is 7. So basically we get the index where we have two pairs. For example 11th, we know that we pick from 2 and 1, which is our, which we found right now. So that will be 1 comma 2. So basically we iterate again for searching for that element. For finding that integer, we can use a data structure called map. So it will help in finding that if it's present or not and at which index it is present. So we can store number as a key, nums of I as a key, and index as a value. So when we need to find any number, we just simply check in map. If it's present, then we also get its index, so we directly get its output instead of searching for one by one we directly get our desired output. Okay, let's talk about this time and space complexity. So basically what we are doing is we are iterating over every element in the array and subtracting it from the target and checking if it's present in the map or not. So that for this we are iterating only single time, so that will be O of n, and we are subtracting it, so that's a constant operation, and we are finding it's on the map. So finding in the map generally takes O of 1 time, but in ordered map it takes log n time, so we can use unordered or order map accordingly. And about the space complexity, we are using map, so that will be O of n, because we are storing n elements in the map, so that will take n space. So that's it for the complexity. Let's jump into the solution. Okay, let's start with the solution. So first we take a map which will have nums of I as a key and index as a value. So we will declare a map of integer, because nums of I integer and also index also integer, so we will take map of integer. Let's name it map, and then we iterate over nums of I. Okay, so for that we can directly use a for loop for nums of size. And okay, so the current element will be nums of I. So target is also given, so we need to required number will be target minus current. Okay, let's assume we are at 0th index, so our required number will be target, which is 9, and 0th index the 2 is present, so that will be 9 minus 2 equal to 7. So we need to find 7 in our map. Okay, so our required nums will be target minus nums of I at index. So currently our map is empty, so this basically our map, it's empty currently. When we iterate we will fill its value. Okay, what we do is we check if map dot find, so it will find in the map if required number is present or not. So it will enter if required num present in map. So if it's not present, then we basically just assign nums of I to index, because we might need to find it in the future. For example, let's check for the 0th index. So 0th index, the target which is 9 minus 2, which is 7. Map don't have 7, so it won't enter in this if statement, and it will insert nums of I to the index. So for now it's add a value which is 2, which have value 0, so 0th index. And in second iteration, when I is equal to 1, so nums of I will be 7. So 7 minus target is 9, so 9 minus 7, which will be a required number. Map will find that number if it's present in the map or not. So it's check, yes, it's present, so it will enter in this loop. Okay, if the required number is present in the map, so we will just need to return it index. So we will create an vector answer. We have two index, for two index of the numbers. First will be required numbers index, and other one will be current. So required number index we can find it in the map, so we will search what will be the index. So basically we are storing, that why we are storing the index as a value. So we will find map of required numbers index, and current number will be having index I, because we are iterating. So okay, so this will be our answer. So we basically need to return that answer. So in this question is there exactly one solution present. So let's assume if it's not present, we need to return empty vector. So we basically can return an empty vector. Let's try and run it. Okay, it's passing this sample test case. Let's try others also. Okay, it's passing. So let's submit it. Okay, so it's submitted. So this is for the solution. Okay, so that's it for this video. Let's see you in another one.